Okay, this is good stuff. We're finding results here. Now, let's create that graph that visually displays for the reader and for ourselves sort of what's going on across time here. Let's see if there's any obvious movements. The first thing we want to do is collapse this to a yearly data set, because the figure is simply plotting 1 point per year for each variable. So what I'm going to do here is collapse. We're going to keep tie in regulation, and conference by year. And actually, I'm going to type this out, but I'm not going to run it yet because I want to show you what's going on. Let's browse the data real quick. I'm going to browse those particular variables, ties, conference, and year. Now remember, all of these variables we're interested in, outside of year, are zeros and ones. So if I collapse this data set by year, and I use the default option, it's going to give me the average value of ties and conference. Well, since these are zeros and ones, the average value is going to be the proportion that end in tie in regulation, the proportion that end in tie, and the proportion of conference games. Just to show you that's the case, let's summarize these variables. Actually, let's summarize them if year equals 1996. Let's look at one particular year. Okay, obviously no games end in a tie. 21.25% ended regulation in a tie, and half of them were conference games. Okay, so now when I collapse the data set, and I spell conference correctly, what it's saying is give me the average value of these variables by year. This should be small enough to list. Indeed it is. And as you can see, we get 0 ties in 1996. We get the average value, 21.25% in regulation, and half were conference games. Now I'm saying these as percents, but they're fractions. So what I want to do here is actually convert these to percents. Now when I do that, I would like to introduce to you the concept of looping. Because what we're going to do is the same operation to all three of these variables. We're going to say replace the value with whatever the value is times 100. That'll move this decimal 2 places, and we can read it as a percent. However, whenever you're doing the same operation over and over in any kind of coding, chances are you can write a loop to automate that and save time. Now this loop I write will be 3 lines of code, which is exactly how many lines it would take us to do this operation anyway, so it doesn't really save you lines. But imagine you're doing this for 100 variables. It can save you a ton of time. So let me show you how we do this. Well, let's first write out, actually let me open a new do file. I'll show you how I typically work through this. New do file. What we would do is say replace tie equals tie times 100, right? Because if I do that, I convert it to a percent. So if I run this line of code and I list my data, I can see that indeed now ties in percents, right? And I was going to do that for these other variables as well. What I was going to write is, you might try to save time, copy and paste this 2 more times. Instead of tie, say tie regulation. Instead of tie down here, we'll say conference. We want to do this to all 3. Okay, that's a lot of typing. It's kind of tedious. And if we had more than 3 variables, it gets very tedious. Now we can do this, but there's a better way to do this. Notice that you're just doing the same logic over and over. You're writing replace over and over. You're writing equals over and over. You have the same variable name here as here, and then you're multiplying by 100 over and over. So this repetitive task doesn't need to be typed over and over. The only thing that changes is this variable name. You basically want to do the same You want to do the same operation for 3 different variables. So we can use a for each command. The command is for each. I highly recommend you reading the help file on that. I'm going to say for each v of var list. Var list stands for variable list. The letter v is something I chose. We could have called it var. We could have called it variable. This is our choice. I'm going to say v, which stands for variable. For each v of variable list, and then I'm going to give it a list of variables, tie regulation, and conference, and then a bracket, curly bracket. You see it gives me a second one. I'm going to delete it because I hate when it does that, but it knows we need to close it later. For each V of varless tie regulation conference, so do this once for each variable, replace, and I'm going to write instead of tie, V. And you notice I put it with apostrophe at the end, and this symbol at the beginning, which is to the left of your 1 key on the keyboard. I don't know what to call that. When I do that, you notice Stata turns this into a sort of fuchsia color. That's because this is the way we refer to local variables. A local variable is a variable that Stata makes up temporarily and then forgets when it's done with it. So what's happening here is I'm saying V is our local variable. I'm going to create a variable temporarily called V. What does V equal? Well, whenever I write V with this notation and it turns fuchsia, Stata is going to plug in the variable tie. And it's going to do whatever I say. And then at the end of this, I'm going to write the curly bracket saying this is the end of the loop. Also, I have a tie here, so let me put V in there. So wherever I see tie, I want to put the V. The way Stata reads this is it's going to say, take the first variable of this list, you just told it was a variable list, and plug it in for V. And it's going to say replace tie with tie times 100. It's then going to hit the end of this loop, that bracket, and it's going to go right back to the start. It's now going to move to the next variable and say, okay, change this local variable V. V now is tie regulation. So it's going to run this again, plugging in tie regulation, where we've written V. It hits the end of the loop, goes back to the top, says now V is the word conference, or the variable conference. Plug that in here, do it again. So let me show you how this works. I'm going to go ahead and delete the rest of that. And let's convert this back to proportions, so that when I multiply by 100, it's not something we don't want. So I'm going to say replace tie equals tie divided by 100. So we're back to where we started. Now when I run this loop, I just click it, and it instantly runs. You can see it made changes 3 times. And now when I list the data, we've got percents. So this didn't save us a ton of time since we were only doing it 3 times. But again, you might have to do some kind of operation over 20 variables, 10 variables, whatever. And this is a very quick way to do so. Another way you could have made this quicker, suppose all your variables started with the word tie. You know, we had conference here, that's different. But suppose we had tie first half, tie second half. I don't know, I'm just making things up. But imagine they all started with tie. One way you could make this even quicker is to use the wildcard for each V of varless tie star. That means for any variable that starts with the letter TIE, the letters TIE, do this. And so if you're clever about the way you name your variables, and they're variables that you need to loop over, this becomes very easy. This becomes very efficient to write. So if you start looping, and you should, other commands you might want to search on help for is for val. This is for when you want to iterate over values, like you want to change the number from 1 to 10 and increase by 1. So you might want to do something for the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You could write something like for value, and instead of V, I just usually say X, but you can choose whatever letter you want, equals 1 to 10, and then whatever you write in here, Stata is going to do. So just to give you an example, I could say display X, just show me that number. So if I run this, you see Stata did exactly that. It displayed 1, because it plugged in 1 for X, reached the end, start over, update X to the next number 2, and so on and so forth. So these are 2 very powerful commands that you use with loops to save yourself a ton of time for each and for val. And I suggest reading the help files on both. Alright, so with that done, let's go ahead and label these variables. If I describe them, you see that after you collapse the variable, Stata labels them as the mean value, which is nice to remind you, what it is, where it came from. But we don't want this displayed in the graph. So let's go ahead and label our variable. Let's call tie %ties, because that's what it is now. It's the percentage. Let's label our variable tie regulation, %ties and regulation, obviously. And let's label our variable conference %intra-conference. Or we could just say %conference. I think that's good enough. Because now it's a percent. It's no longer a 0, 1. So if I describe my data set now, we see these nice labels that make more sense. They're more descriptive. That's great. But actually, we still have this data set label, but our data set has changed. So if you're going to save this, you might want to label the data set again. Let's call this MLS Ties in Conference 1996 to 2012. I don't know. It's a little more descriptive. And I forgot my quotation marks. This data is confused. There we go. This makes more sense. All right, let's start making the scatter. I like to go one step at a time and add things and look at it and see what needs to be added. So first we want to scatter the ties across year. Let's just do a very simple scatter plot. Scatter tie and year. See what we get here. So obviously in the 90s, we couldn't end the entire game in a tie. That's obvious. In the overtime era, we could. And then here we have the modern era where if you end the game in a tie, it's over. There's no overtime or shootout. Obviously, the amount of ties are increasing over time. We see that right away. But we want to add a second scatter plot here. We want to add the ties in regulation. And so we want to use the two-way command that we've used many times before. So let's say two-way, and then I'm going to copy and paste that scatter in there. And then we're going to do another scatter, but tie regulation. So this is something we did, I think, in the first video. Nothing too new. Actually, nothing new at all. And as you can see, it'll plot them both, and it actually chose a second color so that it's easy for us to make out the difference. That's nice. So if we're looking at ties and regulation, obviously that is possible for all years. So that's going to be higher, especially for the 90s. Higher in overtime. And what you notice is after the overtime era, these are all red. That's because it put the red dots on top of the blue. Because ties and regulation are the same thing as ties overall in the current era. If we just look at this graph and we're a reader who hasn't been following this video, that might not be clear. You might be wondering, well, where's the blue dots? So that's something we'll have to think about. Actually, we might want to think about that now. Let's go ahead and deal with that problem now. We can use an option to change the symbols being used. Here we have circles, and I do like circles, but we can also use circles that are hollow. They're not filled with the color. So let me show you how to do that. You want to use the option, which you can read about in the help files, M symbol. M stands for marker. We call those dots markers. And so what I can do is, let's make the regular ties hollow. So I'll put a comma here after scatter because I'm using options. And I'm going to say M symbol, and in parentheses I'm going to write O, O-H with a capital O. Again, you can look up the help file on M symbols, and it'll tell you all the different symbols you can specify. But I'm going to write capital O-H. And what that does is it gives me these circles that are hollow. So you might think of the capital O as a big circle, and the H as hollow. And once we do that, I don't really need these to be a different color, these red ones. So I would actually like to keep these the same color, which is dark navy, I believe. So I'm also going to use an option of the marker color, or M color, to choose the color of each of these. So I'm going to go back to my code, and in addition to marker symbol, I'm going to say M color, DKNAVY, that's dark navy, which I believe that one already is, so it's more important actually that I add the option to the second scatter plot, which uses the regulation ties. I'm going to add M color DK navy. So I'll add that to both to make sure they're the same. Oh, and I'm missing a parenthesis somewhere. Let's see. Oh, right here. I need one to close that. There we go. Now it's starting to look better, right? When the symbols are different, there's really no need to also differ them by color. So this is nice. We can differentiate when we're talking about ties and regulation versus ties overall. But we still kind of have the problem in that the reader might look at this and say, why are we only seeing regulation in those final years? And the reason is because regulation is the same as the end of the game in those years. So we might want to make a note actually in the legend saying, hey reader, by the way, in these years, percent ties and ties and regulation are actually the same thing. So that's going to be a legend option. Let me show you how to do that. So this will be an option for our entire two-way plot. I don't have to put it in one of the scatters. So what I can do is put a comma after everything I've written, right? I'll put a comma here because this option is an option of the two-way. It's not of an individual scatter. So I'm going to put the comma here so that the option refers to the whole graph overall. I'm going to write legend, and then in parentheses, we'll write a note. And for note, you need another set of parentheses. And what I'm going to write in the note is that 2004 to 2012, end of regulation is synonymous with end of game. That is, they're the same thing. So I add that note in the legend, so when the reader looks at those dots to see what they mean, it sees the note saying, by the way, in these years, it's the same thing. So when you only see one dot, it actually represents both. Okay, now it should be difficult for them to be confused. Something that would be even nicer, though, is to separate the eras, because the point here is we want to look at differences not just across time, but across era. So the first 4 years constitutes an era. It would be really nice if we had a line separating era 1 and 2, or the shootout and overtime era. Well, we can do that with the option X line. That is, make a line for some X value and have it go all the way up. So if I go back to my two-way graph, that's getting more complex, but more beautiful. On one of the scatters, doesn't matter, I'll just do the first one. We can add the option X line, and we'll say put a line at 1999.5. That way it's in between 1999 and 2000. Now we can clearly see those first 4 years separate from the rest, but we also want to separate out the next 4 years, which is the overtime era. So I'm going to go back to that X line option and add another number with a space, and the next break is at 2003.5 because we want it to be between 2003 and 2004. And now we see 1, 2, 3, 4 more years in an era, and the rest are just the current era. So yeah, looking at this, we see the differences. It looks like ties, obviously at the end of the game, are impossible in the first 4 years. They're low in the next 4 years compared to the current era. And we see there's a difference between regulation and the end of the game overall, but only for the first 8 years, or the first 2 eras. That's a lot clearer to see now. All right, how can we improve this even further? Well, I guess it's okay to have percent ties and regulation in the legend telling you what these dots mean, but we typically have a Y title describing that. So let's add a title and then alter these dots again. This is just a style issue, but I think the changes we make will be for the better. And instead of year, let's say season. Obviously they're the same thing, but we're talking about sports, so let's just use the word season. So what we'll do is, in the first scatter plot, you can do it in either. I'm going to say let's give ourselves an X title. We've done this before. Let's call that season. I guess we don't need to capitalize it. And let's give a Y title. Let's describe this as percent of games tied, because that's what we're looking at, right? That's what the Y-axis represents. And now, since we know the height of this dot is the percent of games tied in that year, we don't need to say percent ties. We could just label this as end of game, and the solid dots as end of regulation. I think that makes it clear. To do that, I will return to my legend, and separating the note with a space, we will say label, and then in parentheses 1, which means the first dot, call that end of game, and then I'll have another space, label, parentheses 2 for the second set of dots, end of regulation. So if I add that within the legend, you see the changes are made here. And again, maybe it's not necessary to capitalize that. That looks too formal. Let me change that. These are not proper nouns. I'm not sure if you're supposed to capitalize in legend. I'm sure there's some style guide somewhere, but I'm going to not capitalize because this is my video. Okay, there we go. Now it's clear. The y-axis is labeled as the percentage of games tied. The reader might then think, but why are there multiple observations with multiple symbols? You look down at the legend and you see, okay, the hollow ones are the end of game and the solid ones are the end of regulation. But now that I think about this, this might be OCD of me, but regulation comes before the end of the game. So it might make more sense to swap the order of these two. And again, I'm just being OCD now, but in doing so, publicly here for you in the video, you can see how you can make some changes if you want to. These are not all necessary, but I figured I may as well show you how to do this. Let's return to our legend. Let's be very nitpicky here. I'm going to add another thing in the legend, and that is order. In parentheses, I'm going to write 2 space 1. What that says is I want you to change the order in the legend, show me the second graph first, and the first graph second. So the order is 2, 1 here. And you see that just swapped these two. Now, could I have changed the order of the scatter plots? Yes. But I didn't feel like it. Okay, now our graph has a lot of detail. I think it's very difficult for the reader to get confused. Things are in order as they should be. Regulation occurs before the end of the game. Yes, I know it's a legend, it doesn't matter, but it bothers me. The last thing I really don't like, though, is the way State is labeling these seasons. It doesn't label each one. And also, it starts with 1995. We don't have a 95 season. It goes all the way to 2015. Stata does this because it has these automated procedures where it calculates what might look nice given your data. And this does look nice, but there's no reason for this blank space. It's too much. We don't have this year. I don't want the reader thinking we have these years, and for some reason we just didn't calculate their values. So one way you can control what's displayed here is by using the option X label. So let's go back to our now ginormous line of code, and within the first scatter, I'm going to add another option. That's X label, and in parentheses I'm going to write 1996, which will make it start there. Then in parentheses beside that I'll write the number 1, which says increase 1 at a time by 1 digit, and the last number I'll write is 2012. What that says, if you can see down here, is start with 1996, increase in units of 1, go all the way to 2012. That's our X label. And we now have all of our years, but boy does that look ugly because they're overlapping with each other. This is a common issue in Stata. Well, there's many ways we can fix this. I've come up with a solution though recently that I just discovered that I think makes it look very nice. Instead of shrinking the numbers and making them tiny fonts that's hard to read, or changing the years to 96 instead of 1996, we can change the angle of these to be 45 degrees. So I just recently learned this. Let's go back to our line of code, and we'll add this other option to the scatter plot saying angle. I want you to angle these things. Oh, I'm sorry, not the scatter plot, the X label itself. So within the X label, I'm going to add a comma and give an option. And now you're asking me, wait a minute, you're giving an option itself? Yes, we are. That's how detailed we can get. So within the X label option, we're going to say angle these labels, and in parentheses I'm going to write 45, which means 45 degrees. Oop, and it says angels are not allowed. That's okay, because I really want an angle, not an angel. Look at that. That is beautiful. We don't have to sacrifice the year labels. We can have each one. We just angle them so they don't overlap. Now, I don't know about you, but this is one of the most beautiful graphs I think I've ever seen. And all we're doing here is visually displaying data in a way that the results are almost obvious. We're not doing any tests here. We're not doing any statistics. There's no model. I'm just showing you data. But there's so much information here. Obviously, the ties in regulation were very low in the shootout era. They were higher in the overtime era, and somewhat higher, it looks like, in the current era. The other thing we're conveying is that in the overtime era, there were games that were ended in sudden death overtime or golden goal overtime. Look at the difference between those hollow points and the solid points. We also see in the tied era, the shootout era, it's impossible to end the game in a tie. That's clear from all the hollow points at 0. Those red lines are really nice, good contrast with the blue dots, and it makes it really obvious for us and easy to separate the eras. Now I know what you're saying. This is beautiful, but you want more. We should also convey information about the conference versus interconference games and try to see if there's any evidence that there are more or less ties across type of game. Well, let's apply some of this to that data. Let's go ahead and scatter the ties across conference, or ties in regulation. Let's do that one. Scatter tie regulation and conference. Let's just start there. Okay, well, it looks somewhat downward sloping. Let's take a look at what it looks like if we do ties overall, which I know were not possible in the 90s, but just out of curiosity. Scatter, tie, and conference. That looks interesting. There's a clear downward slope there, and obviously these should be years in the 90s where it's not possible to tie. Let's go with this one, just for fun. Let's take a look at displaying information on the percentage of ties in the game overall versus the conference games. So I said these two dots are probably the 90s, but we might want to know that for sure. And what we might want to do is display era here by changing the colors of the dots. Obviously our dimensions are percent ties in conference. I can't add a third dimension of time or year, but we can differentiate the eras by giving each era its own colored dot. Now how do we do that? I will show you. We can do another two-way, and let's think about making 3 scatter plots, 1 for each era. So I'm going to say scatter tie year if era equals the shootout. Oh, we don't have the variable era. We could make it, or we could use years. Let's go ahead and make it. I'm going to generate era equals shootout if year is less than or equal to 99. I'm going to replace era equals overtime if year is greater than or equal to 2000, and year is less than or equal to 2003. I'm going to spell year correctly. And then I'll replace era equals ties if year is greater than or equal to 2004. I'm just going to check and make sure those years are good. They look good to me. Okay, so now we will make a two-way scatter plot. I'll just start with 1. Show me the shootout era. There should be 4 dots. There is. And there are no ties. That's at 0. Makes sense. Now we can add another scatter plot, which is the overtime years, on top of that. And it gives us a different color. And now I can add the last era, ties. That should give us a third color. And there you have it. Oh, but I'm doing the wrong graph. We want to do conferences, so let me run that again. I want to do tie and conference, not year. Conference. This is why it's very good to use this history to just click and so you don't have to type everything all over again. And there we go. Okay. Now, it's not the easiest to read. Some of these dots are overlapping. You can see a little red poking up here, and maybe even a blue, which makes it difficult to see. The legend has everything just percent ties, so we don't know how this is being separated. So first thing we might want to do is fix that legend so that we know what we're looking at. We know how to do that now. We will add a legend to the two-way option, and let's label 1 shootout. You can label 2 as overtime, and label the third set of dots as ties, I guess we could say. Okay, now we know this makes sense. Great. Because in the overtime era, that's where we saw the seasons that were 100% between conference rivals. Again, there were 3, quote, divisions, but they used a single table for playoffs, so those were essentially treated as all conference games. These 0% ties are indeed from the shootout, as they should be. However, we should have 4 dots. I'm only seeing 2. They might be overlapping. That is, there might be 2 dots here and 2 dots here. And we have some more overlapping up here. So we're getting there. This is better. At least we know what colors are which era, but it would be nice to know what years we're looking at. We can do that with marker label options. So here's what I'm going to do. In each scatter, I'm going to say, I'm going to use an option, label, which is marker label. It's going to label each one of those dots, and I'm going to write in here year. So what this is going to do is say, put a label on top of that dot, that marker. I'm going to do this for each one. Put a label on top of that that shows me what the value of year was for that point. Now this is getting nice. We're starting to see the years. As you can see, there is overlap. I see 96 and 7 here, 98, 99. There's overlap of dots, years, and eras. This is a hot mess. So obviously we got to fix some stuff. Now, this is a bit advanced, but it's worth your time to learn. Stata automatically puts the position of all of these labels at 3 o'clock. If we think of the circle around here as a clock, this is the 3 o'clock position. We can tell Stata to change that position, and we don't actually want to change it for all of them, so this 2012 looks nice. 6 and 5 look nice. These two, I don't even know what they are. We want them maybe written in the 9 o'clock position so I can actually read them. And as for these, maybe 1996 is fine here, but we want to pull out 7, maybe put it at 12, so I can read both at the same time. So let's start identifying some of these to change. The easy way to do this is to actually create a variable whose values are numbers, and the numbers correspond to the clock position you want this label to display as. Once we make that variable, we can then tell the two-way graph to use that variable to place each of these years. Now let me show you what I'm talking about. If I say generate, let's call it position, the position variable, equals 3. All right, if I look at that data, it's just a variable that equals 3 for everything. That's the 3 o'clock position. If I look back here, that's the position all these numbers are in. So if I tell Stata, go back to my two-way, in each scatter, if I add the option mlab v, which is the marker label variable, I think that's what it stands for, and parentheses, I'll write position. That's the variable we just made. It's going to enter the number 3 for every row. That's the marker label variable. I want to do that for each scatter to make sure they're all doing it. And here. Now this isn't going to change anything because they're already at position 3. Oop. I just want to make sure I'm putting it in right, which I didn't. Let's see which one's wrong. Actually, I'm missing it here, so I should put one there. Here's the second scatter. I should put it here. Or I just clicked a different thing. And I'll put one here, and that should be good. Ah, I see the issue. This comma is for the two-way. I want to put it within this parentheses. That's probably what I did. There we go. And nothing changes because I've told Stata to put each label in the 3 o'clock position, which it already did. But now let's look at ones we want to change. These should be 2001 through 3, even though we only see 2 dots. They should be overlapping because those are the 3 years where every game was on a single table. So let's change these to the 9 o'clock position. So what I'll do is I'll say replace position equals 9 if year is greater than or equal to 2000 and year is less than or equal to 2002, because those were the 3 years that it happened. I see there's 3 changes made. If I look at the data, what this is going to do is it's going to tell Stata to put all the labels in the 3 o'clock position except for these 3 years. Now when I run the exact same two-way graph command, you see that it flipped these to be in the 9 o'clock position. Now here's the ones that are overlapping. Now I can see them. That's 2000 and 2001. So let's put 2001 maybe on top here. Let's replace position equals 12, that's noon, if, or 12 o'clock, year equals 2001. Now let's take a look at what that looks like by running the two-way again. Much nicer. Now we can see there's actually 2 points here, and it's pretty clean to read that. We understand that's the same point. And we can do the same thing to fix these 90s. Let's put 6 on top, and there should be 8 on top. So maybe in your do file you want to say replace position equals 12 if year equals 2001, 96, or 98. Another way to do that is to use the enlist command we've used before, enlist. If year is, well here I'll just do the 90s, 1996 or 1992. 8. Let's take a look at that. And this is starting to look very nice. Are there any others? Yes, there's a hot mess here and here. So this is 2009, it looks like. We can switch that to 3. And, what is that? That's 2003. Let's put that to the left. So 9 and 3 should be 9 o'clock. So I'll reuse my command. I'll replace the position at 9 o'clock for the years 2003 and 2009. I think I said. We'll find out. And we're looking good. I think that clears up all the issues. We might want to add the note, however, again, about why these are all 100%. I don't think it's necessary to add it to the legend. We can just add it to the graph. And so we can basically add that note to any of the scatter plots and it'll show for everyone. So if I go back to my command, I'll just add it to one of the scatters as an option. I'll add that note in parentheses. And now it tells the reader, hey, by the way, these 3 years, the seasons used a single table for postseason entry. That's why you've got this cluster at 100%, by the way. The last thing I think I'd like to change here is this legend. I don't like this empty space. I like for things to be even. We can make this be just one row. You can make it one column if you like, but I think it'd be better as a row. So I'm going to add to the legend the option of using only one row. The way we can do that is go into our legend, where we labeled everything, and I'm going to type row in parentheses 1. It says just use one row in the legend. I think that looks a lot better. Okay, this is great. So here we can see the 90s didn't allow ties. We can see that they're blue. That's all the shootout era. That makes sense. We see the overtime era had 1 year that looks like every other year in the current era, the era of ties. And we might be tempted to think, oh, hey, in general, the shootout has much lower ties. Look at this. And maybe it's because it's the overtime era. Or maybe it's because they were all conference games. It's hard to say. But we get that point here because we see not only are they all 100% conference games, these 3 years, but also the red tells us they were in the overtime era. So, maybe it's difficult for us to separate what's going on here. If the conferences are what matters, we should see a downward sloping line in the conferences. Well, if I look at the green dots, which is the tied era, we do see a downward sloping line. Now again, the beautiful thing about separating this is we can't speak much to conferences when it comes to the shootout era because there weren't ties. We can't speak much to the conferences and how they matter in the overtime era because we had these weird years where there was basically one conference for playoffs. And so we can see that those are weird eras. But now if we look at the current era, which is in green, we do see that downward sloping line that we would expect. And so here's, sort of another way we can use this two-dimensional graph to look at actually multiple dimensions. By using color, that gives us sort of another dimension here. And actually by using the year labels, you can eyeball, it's not that easy, but you can eyeball changes across time by looking at those numbers. So this is sort of a way to try to, shoehorn in there additional dimensions that we're not actually adding, right? This is not a four-dimensional object, but it kind of is, right? When we're looking at the value of the numbers and the colors. All right, so by now you have what took me probably 15 years to figure out in terms of how to display data in a beautiful way using Stata. I know this is a lot. You might not need all these options, but if you ever feel like you do, now you have the video to come back to remember how it is you could do it. In the PDF, I give you a lot of suggestions of help files to read and how to find these options. It's not easy. The way to find these is to look at typically the help file for two-way or scatter, look at their options, click the links for other help files, and then sort of go down a rabbit hole till you find what you're looking for. It does take forever. Like I said, this is maybe 15 years of me tinkering with plots. Not constantly, not every day, but over time. And so hopefully this helps you out and saves you a ton of time, and you make beautiful graphs for me to look at. Because now what you'll be doing in the assignment is taking this knowledge and applying it to the substitution patterns of the same data set. So have fun with that.